That question number 8, I think. No, question number 9 we did, I think. Question number 9, how many words with or without meaning? I think question number 9 we did. See, in all such questions, we use the formula NPR. Again, see the meaning of NPR. The meaning of NPR is the number of permutations. Permutations means the number of arrangements out of n things if r things are taken together. Out of n things, r things can be arranged in NPR ways without repetition. So all such questions of numbers, few digits will be given. If 7 digits are given, using the 7 digits, how many 4-digit numbers can be written formed without repeating a digit? Using 7 digits, how many 4-digit number? So using 7, 4 are to be arranged. So it is 7p4. We use the formula NPR. Using 7 digits, if all digits are used, it is n factorial or 7 factorial, because NPN is n factorial. So these are the only on 12 HD again. So these are the only again the same thing, the number of alphabet letters, the number of words. In fact, words also, English words are also, we get words by the permutation of alphabets or letters. Permutation means arrangement of letters. So arrangement of letters. C, using ACT, using the letters ACT, and using these letters we can form different words. Again, using the 3 letters, how many different words can be formed with or without meaning? Using 3 letters, if you are reshuffling the 3 letters, 3 factorial ways. So 3 factorial means 3 into 2 into 1, 6. In all, 6 words can be formed. Without, definitely few words will be with meaning, few words will be without meaning. So those starting with ATC, ATC doesn't have any meaning. ATC have a meaning. Airport traffic control is there, but as a word there is no meaning. ATC. Then starting with C, it can be CAT, CTA. Starting with T, TAC, TCA. So here, these 6 words can be formed using 3 letters. So 3 factorial ways. 3 factorial, 3. These are all 6 words which you see. So all words are reshuffling of letters or permutation of letters or arrangement of letters. Definitely, these are few are act, this is a word cat, this is a word cat. These are with me. So in our question, with or without meaning means total number of words. These are the total number of words. So here 3 letters are used, 3 factorial ways. Again, out of the 3, if 2 are taken, again 3p2 ways. 3p2 ways is again 6 only. So this is how to form words or how to form the numbers we discussed. Again, while forming the number of words, if a letter is repeated, then it is n factorial by p factorial. N factorial by p factorial. This is the n factorial by p factorial, because if, for example, if it is, this one we wrote ACT, right? ACT. Each of this is what we wrote this one. Each of them, if it was AAT, if it is AAT, again starting with ATA, that's all, right? Then starting with T, A. That's all. See here, out of N, we have 3 letters. If all 3 were different, 3 factorial, we have seen earlier. This ACT, this all 3 letters were different. So we could arrange them in 3 factorial ways. Total of 6 words we have seen. The previously 6 words I got, right? Whereas out of the 3, 2 are repeating. Then it is n factorial by 3. So 3 factorial, this 2 are repeating. 2 factorial. 3 factorial by 2 factorial is 3 is 3 words. See, these are 3, 1, 2, 3. 1, 2, 3. So with A and T, these are the only 3 words which can be formed. So out of n objects, if P objects are repeating, if P are of the same kind, if P are of the same kind, here out of 3 letters, 2 are of the same kind. Out of n letters, if P are of the same kind, n factorial with P factorial. So exactly same. Out of 3 letters, 2 are of the same kind. So total number of words which can be formed is 3 factorial by 2 factorial. So that is 3 ways. Husaifa is in the waiting room, please. Husaifa, I told them, if you are late, then whenever the same kind, out of 3 letters, here 2 are of the same kind. So 3 factorial by 2 factorial 3. We know that with these 3 letters, only these 3 words can be formed. Now coming to question number 10 and 11. This question number 10 and 11, these 2 questions are, yes, Taranjan, I don't know, 45, what is it, 45? Taranjan wrote something. Okay, by mistake. Okay. Now, so this question number 10 and 11, these questions, exercise 7.3, question number 10 and 11, especially this question number 10 or similar question. Most of the time, exactly same question. This question is the maximum repeatedly asked question. This question was asked most of the time. If you are checking 10 years question paper, you can see at least 7 or 8 times the same question has come. So it's very important. See here, the question is, in how many distinct permutations or in how many ways the letters of the word Mississippi. So the given word is Mississippi. Mississippi. In how many words all 4 I's do not come together, or 4 I's are not coming together? Such questions. See here, first of all, we will find what is the total number of permutations or the total number of possibilities, the total number of words. Here, the total number of words out of n things, if all are to be arranged, it is n factorial. Out of n things, if p are of the same kind, n factorial by p factorial. So here, first of all, in all such questions, what to do is check whether we have any repeated alphabet or repeated letter. In the previous questions, Monday and equations, we have seen there were no repetitions. There were no repeated there were no letter was repeated. Whereas here, you can see inside we can not put here we can write. Yeah, how many times can we say here is only 1? That is I. How many times? 1, 2, 3, 4 I's are there. Yes. 1, 2, 3, 4 yes are there. I we counted yes, we counted P. P 1, 2 P's are there. Okay. So total 10, 11. Check it whether 11 letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. That means we didn't miss any letter, we counted all letters. In this letter, in this letters, 11 letters, out of this 11 letters, we have 4 I's, 4 S, and 2 P's. Total of 11. Out of n letters, if P are of the same kind, n factorial by P factorial. So out of 11 letters, these are of the same kind. Therefore, total number of letters, total number of words will be 11 factorial by 4 factorial into 4 factorial into 2 factorial. Why is it so? We use the formula n factorial by p factorial, which we wrote before vacation. Out of n things, if p things are of the same kind, the total number of arrangements will be n factorial by p factorial. So here, out of this 11 letters, we have 4 I's are there, 4 S are there, 2 P's are there. So the total number of arrangements will be using this formula, each of P. If P things are repeated, here P things, another Q things, other things are repeated. So here, instead of n factorial, we use same formula n factorial by p factorial. This p factorial, we have more than one repetition. More letters are repeated. That's why we got 4 factorial, 4 factorial, 2 factorial. This is the total number of words. In all such questions, to find the total number of words, first see the total number of letters. After seeing the total number of letters, write the number of repetition. Again, taking this letter, taking each letter, write it, add up total 11, then count it so that no letter is missed. So total 11 letters are there, out of which 4 and 2 repetition. So total number of words is 11 factorial by 4 factorial, 2 factorial, and simplify. Simplify 11 factorial, we can write 11, 10, 9, 8, 7, 6, 5, 4 factorial, because 4 factorial is 1, 4 factorial is there, we can cancel it. This 4 factorial, 4, 3, 2, 1. This 2 factorial, 2 into 1. This 4 factorial cancels. Now 4, 2 and 8 cancels. 3, 2 and 6 cancels. Multiply, divide. 9 5s are 45. 9 5s are 45. 45 11s are 45. Is it? I understand. The 45 is 7. I understand. Multiply these numbers. Multiply these numbers. So this multiplication with 10 and 11 will go enough. So 9 7s are 63. 63 into 5. 315. Into 11 means 315 2 times. So 315. Into 10 means 10. Check it. Is it 3 4? Do the multiplication. Three four six is someone. It is 3 4. This is the total number of words. See that to find the total number of words, we use n factorial by p factorial. Total of 11 letters. Of this 11 letters, we have seen this 4 I's, 4 S's, 2 P's coming together. Now, the question is not to find total number of words. We need to find in how many words this 4 I's do not come together. It's an interesting one. To find the words where 4 I's do not come together, what we do? First, we will find the number of words where the 4 I's come together. See, if 4 I's are together, this 1, 2, 3. If this 4 I's are together, this 1, 2, 3, 4 I's are together. That will act as one block. That will act as one letter because 4 I's are together. That we can consider this occupy one place, or it is inside a box. It is inside a box. So this is inside a box. Remaining, how many letters are left? Remaining for 1, 2, 3, 4 I's are going. Remaining 1, 2, 3, 4, 5, 6, 7. Remaining 1, 2, 3, 4, 5, 6, 7. Isn't it? Remaining 7 places are there. 4 I's together, remaining 7 letters. So this 7 places, 7 letters means we have to arrange 7 places. So total in all we have 8 places. We can take it as 8 different letters. 8. Why 8 different letters? This 4 I's come together in a box, that is considered as 1. Remaining 7 letters. So total of 8 places, or total of 8 objects we have. Instead of n, we have 8. Of this 8, here you can see, here we have 4 yes, 4 yes, then 2 P's. In this 7 places, we have 4 yes and 2 P's because the 4 I's are together. So, while considering this arrangement of this one, in all we have 8 objects, or we have 8 letters. 8 letters means this 4 I's are together in a box. That is considered as 1 letter. The remaining 7 letters are there. So total of this box and 7 means 8 letters or 8 places. Of this 8, we have 4 yes and 2 P's. So the number of arrangements, if 4 I's are together, will be this 8 factorial by 4 factorial into 2 factorial. Why? Because if 4 I's are together, that acts as, that is inside a box, considered as 1. Remaining 7 letters. Remaining 7 letters. So total of 8 places. Why 8 places? That 7 letters and that box. 8 places. In that 8 places, we have 4 S and 2 P. So write it. If 4 I's are together. If 4 I's are together. If 4 I's are together. Draw this figure also. If 4 I's are together, they act as one block or one box. They act as one box or block. Remaining 7 letters. Remaining 7 letters. remaining 7 letters. So total of 8 places. So total of 8 places. I repeat it once again. If 4 I's are together, they act as one block, remaining 7 letters. So total of 8 places. Total of 8 places, of which 4 F and 2 P's. Of which 4 S and 2 P's are repeated. Of which 4 S and 2 P's are repeated. 4 S and 2 P's are repeated. Draw this figure also. We have 1 forest, then 1, 2, 3, 4, 5, 6, 7. So total of this is what we discussed. Those 4 I's will act as one block. We consider that as one letter. Remaining 7 letters. So total of 8 letters for 8 places. For each letter, 1 place. So total number of places will be 8. I think you got the idea. Those 4 I's together, that is 1. Remaining 7. So total of 8 places. Of this 8 places, we have 4 S and 3 P are repeating. This we cannot, because this is inside one box. So 8 factorial. Therefore, total number of words. Therefore, total number of words where I's are together. Total number of words. Total number of words. Total number of words I's are together is 8 factorial by 4 factorial, 2 factorial. 8, 7, 6, 5, 4 factorial. 2 into 1. This cancels, 2 cancels, 3. Multiply 8, 7. So 56 into 15. Multiply it. In the meantime, I will take the attendance with your new roll number. One of you wrote 8. Is it 840? Okay. This is 840. Not over. See, here, this is the number of words where these 4 I's come together. And what is our question? Our question is the number of words where the 4 I's do not come together. So how to find it? We know the total number of words and we know the number of words I's together. So therefore the answer for us, therefore number of words where I's are not together. I's are not together is equal to 34650 minus 840 subtracted, we get the answer. 3. So if I's are together, subtract it. Okay, I worked 3, 3. 33810. I think maybe like 33810. This is what you said on subtraction. Okay, now see it once again. Here, total of 11 letters. So the total number of words will be, we use n factorial by p in all such questions. See, write each letter and see, write number of repetitions. Check whether it is repeated in all such questions. We can see that in all 11 letters are there. In that 11 letters, we have 4 I's, 4 S, 2 P's. So using n factorial by p factorial, total number of letters will be 11 factorial by 4 factorial, 4 factorial, 2 factorial. This is the total number of words. Now, if 4 I's are together, these 4 I's will be inside one. Remaining that 4 I's will act as one letter. Remaining 7 letters are there. So total of 8 places. How 8 places? 1 for this I, because I's together is considered as 1. That one block, remaining 7 letters. So total of, yes, Hamza. If it is yes, yes. Instead of I's, if 4 yes are together, still the answer is same. Instead of 4 s, if 2 I's are together, then no, this one, P, 2 P's are together. If it has 2 P's are together, then here only 2 P will come. Remaining 9. Is it? Remaining 9 letters are. If 2 P's are gone, remaining 9. So total of 9 plus 1, 10 places are there. In that 10 places, 4 factorial repeating. So instead of here, it will be 10 factorial by 4 factorial into 4 factorial. That is another possibility. Then, so here, if 4 I's are together, so 4 I's together, remaining 7 places, so total of 8. In that 8, 4 S and 2 P. Again, another possibility. See, I will discuss different possibilities here. If, same question, if number of words where P's are not together, if P's are not together, this 2P will act as 1. 2 P's, this 2 P's are gone. Remaining 4 plus 4 plus 1, 9. So remaining 9 places. So remaining 9 places. Is it? So this 9 plus 1, in all we have 10 places. So remaining 9 places I will mark. Remaining 9 places means 1, 2, 3, 4, 5, 6, 7, 8, 9. Remaining 9 places. In this 9 places, see, the 2 P's are gone. In this remaining 9 places, we have 4 yes are there and 4 I's are there. This 9 places plus this one. So total of 10 places. So the total number of arrangements will be 10 factorial by 4 factorial into 4 factorial. This will be the total number of arrangements where 2 P's are together. Then to find the number of words with P's are not together, total number minus this one. This is if 2 P's are together. Now, one more case, another interesting case. Suppose that instead of this 4 I's together, if it was A, B, C, D. This A, B, C, D is together. If A, B, C, D is together, see A, B, C, D is together. So instead of 4 I's, it is A, B, C. Okay. If A, B, C, D is together, again remaining 4 plus 2 plus 1, remaining 1, 2, 3, 4, 5, 6, 7 places. Remaining A, B, C, D we have taken out. This instead of 5 A, B, C, D, remaining 1, 2, 3, 4, 5, 6, 7 places. So total of, in this 7th place, you can see 4 yes and 2 please. So here, total 7 plus 1, 8 factorial by 4 factorial, 2 factorial. But one more difference is there. This ABCD is one block. But that ABCD can be reshuffled among themselves within the box. Inside the box, this ABCD can be reshuffled how many ways? 4 factorial ways. Why 4 factorial? 4 digits are there. ABCD, ACDB, ADBC, ADCB. Again starting with B, BACD, BCDA. Because these 4 letters can be arranged within themselves, inside the box. Inside the box, this can be arranged in 4 factorial. So this much into 4 factorial also will come. Why? Because this ABCD, they are different letters. Within the box, inside the box, it can be arranged in 4 factorial. Then why is it not used here? Because here all are i's inside the box. Even if you are reshuffling those i's, it doesn't make a difference, is it? Whereas inside the box, if the letters were different, that also can be arranged inside the box in that many factorial. If you have 4 letters, 4 factorial ways. 3 letters, 3 factorial ways, right? So these are the different possibilities. So we'll stop. Remember this question for Mississippi. First, we have taken total number of words 11 divided by 4 factorial, 4 factorial, 2 factorial. We use the formula n factorial by b factorial. If 4 i's are together, 4 i's comes within a box, remaining 7 places. So total of 8 places. Total of 8 places because that's 7 letters and this box. Total of 8 places. Of that 8 places, we have 4 yes and 2 p's. So 4 into 2. So 8 factorial by 4 factorial, 2 factorial. This is the number of words where all i's are together. The question is all i's are not together. So total number of words minus i's are together is i's not together. Again, here all i's are together. All those 4 i's are identical, same thing. Instead of identical letters, if it was for different letters, inside the box, within the box also it can be arranged. That is what I found next. So, any doubts? So we'll meet in the next class. How many words can be from this word? Okay, Amar, you asked one question. That count the total number of you wrote a long word. Number of words, total number of words, total number of letters divided by number of repetitions. That's all. That is a basic question. What will be the word? Total number of letters divided by number of repetitions will give the total number of words. So see you tomorrow.